Bismillahirrahmanirrahim. So we were talking about water quality management in the rivers, and the objective is to control the discharge of pollutants so that the water quality is not degraded to an unacceptable level below the natural levels which are acceptable. So another important thing before going into these detail of these pollution zones, our pollution load coming from different sources is already treated in most of the cases, and it but still it has some value. For example, if we are releasing some effluent from a treatment plant, we are supposed to reduce the value of that BOD up to 80 milligrams per liter, and that value is already within the limits. But the available 80 milligrams per liter still have some quantity of organic content with it. So now actually we are dealing with that quantity, and in some cases, if the situation is worse, then maybe we are also concerned with the um, um, higher pollution loads, and we must reduce that load. Now if you observe that our wastewater source is being added from this pollution source into the river, while our this curve, this black curve, which is actually showing the level of oxygen, it was initially having maximum level of saturation in clean zone, but now we are entering into a decomposition zone. Now you observe that the pollution is being added, the organic content is being added, and the level of oxygen is abruptly reducing down, and it's continuously reaching a minimum level. So this minimum level is actually the called the critical deficiency of the oxygen level. This is the lowest level up to which the oxygen can deplete in this case, in this scenario, with this much addition of the pollution. And then after decomposition zone, we are entering into a septic zone. What is septic zone? It is a very worse scenario of anaerobic conditions, where we have anaerobic microorganisms actively participating. So it is going to have the maximum level of the decomposition. So that's why you can observe that we are achieving the critical deficiency in the septic zone. So then we the curve entering into septic zone, and then if you further move forward, there is another zone which is called recovery zone. Now here is something to be clarified, that the oxygen, while being depleted, is being consumed by the microorganisms, but at the same time the oxygen is also entering into the system as well. So this is called reoxygenation. So this first of all, this depletion is called deoxygenation, and this addition of oxygen from the surface is called reoxygenation. So because of this reoxygenation, this process is continuous, and it is you will see that it is getting nearer on the extreme end, and in this case the oxygen is being continuously added up into the system. So while being decomposed, now level is reached when the organic load is gradually reducing. So the rate of deoxygenation is reducing. So just try to understand what is rate, because this rate is important to understand the speed of the decomposition. So this decomposition speed is gradually decreasing. Now then similarly uh, the oxygenation reoxygenation is also being added up, and then it is also in the same process. And in the recovery zone we are getting the oxygen being added, and the presence of different kinds of aquatic life, including this fish, is an indication that the level of pollution has sufficiently reduced. Then again we will be entering into the clean zone, and in this zone we will be having again the same level of saturation as it was existed in the uh, initial clean zone. So almost the same level